Good morning. All right, we are ready to start chapter 17, getting close to the end of the book. So this is going to be section 17.1, more measuring. We're going to be doing triangles. So it's time to return. I'm on page 333. It says chapter 17 at the top. It's time to return to our study of shapes. Before we took a detour to look at exponents and square roots, we had explored finding the area of rectangles, parallelograms, and squares. Now we're going to build on that knowledge to find the area of a very common shape, a triangle. Now take a look at this triangle. Any idea how to find the area? Okay, let me stop for a second. The windows are open because it's really nice outside, and my little ones are right out here playing, so you probably hear them screaming and playing. So that's just what that is. Anyway, we'll try to focus on our math. So look at that triangle right there in the center of the page. It's 2 feet up tall, up high, and then 4 feet that way. But it is hard to find the area of a triangle because it's only part of an object. Remember in math, we try to work from what we know to find what we don't know. Notice this triangle could be thought of as half a rectangle. Now, obviously each half would half the area of the whole, so our triangle will have half the area of the rectangle. Now if you think about it, I'm going to show you this. If you think about a triangle, so any triangle is half of a, what am I trying to say? Let me spit it out. It's half of a rectangle. I'm getting sidetracked. Any triangle, it doesn't matter. So it would require, if you added, well, let's do it this way. If you added, let's see, how would a good way to do this? I'm trying to figure out a good way to show you this. Because every single triangle is actually half of a rectangle. So I'm going to try no, I better not do that. Let me see. Maybe if I could just draw a line, maybe it would show you better. Okay, I don't know. Yeah, I don't think it's gonna show you. But anyway, you can't really see it now. But if you were to finish this, you're actually, yeah, you can actually see it. Let me get you another. Okay, let's see. Well, these are not just real friendly. Here we go. All right, see now. Oh my goodness, here we go. Well, dear. Anyway, if we were to draw a straight line this way and this way, if you kind of tilt your head to the right, it's a rectangle. It just has a line going through the center, but it's a rectangle. Okay, every single triangle you see is half of a rectangle. Every one. So if you know the area, the formula for the area of a rectangle, which is, what is it? Length, 2 times the length plus 2 times the width, then you're going to know the triangle, because then you just have to take half of that. At the very bottom of the page, it tells you the area of the rectangle that they show you there. See, they added on that gray part, and it forms a rectangle. So they went ahead and then that shows them what the rectangle measures. It's 2 by 4. So they multiply that and they get the area as 8 square feet. All right, so then they take, I gave you the area, the perimeter of the rectangle, but yes, the area is where you multiply it. So the area of a triangle is going to be half of that. So it's going to be half times 4 times 2. So you get 4 square feet, because it's half. All right, let's turn the page now that I've got you nice and confused. All right, at the top of 334, what about triangles like these below? How can we find their areas? Well, these triangles obviously won't be half a rectangle the same way the right triangle was. What about their other parallelograms besides the rectangle? Or what if the triangle fit inside a rectangle differently? Could these triangles still equal half of a parallelogram? We're going to try drawing a parallelogram around each one. Now, the gray on the now right under there, they've got A, B, and C. The gray part is the part that they've added on, okay, to the rectangle. So if you'll look up at the very top and you see A, that's like an equilateral. That's like the one I had here on the screen. They've brought that down and they've drawn two little triangles on the side to form a rectangle. They've done the same thing for B and they've done the same thing for C. Notice how each triangle is exactly half the parallelogram that they drew. While this is easiest to see in diagram B, the same holds true for A and C. In diagram A and C, the perpendicular line that we drew forms two sets of right triangles that are equal to the right triangles in the gray area, which means half the parallelogram is the triangles and the other half is the gray area. In all three of these, the height of the triangle, the perpendicular line that they drew, is the height of the parallelogram. Now back in chapter 15, we saw that you could find the area of any parallelogram by multiplying the base times the height. There's you a picture of one there. The area of a parallelogram is base times height. So to find the area of these triangles, you just need to find half the base times the height, since they represent half the parallelogram. Remember, the fraction line means to divide. I'm looking over on the left-hand side. Means to divide. So base times height over 2 means base times height divided by 2. So it looks fancy as, you know, when you write out the equation, but it's really not. So look at the very bottom of the page. So the area of a triangle equals half times base times height, or you can write it fancy ways over that. And it kind of shows you how to write that formula. The top of page 335, it kind of writes out that formula again a little bit for you. So at the top of 335, right underneath those formulas, there's a note for you. Remember, when dealing with symbols like letters, we'll often omit the multiplication sign and write the letters next to each other as a shortcut. We treat letters that are written next to each other or next to a number as a sign to multiply. So you have A equals, A stands for area. They showed you on the first one this, which means area equals base times height divided by 2. Okay, if you take this out, this is all this is trying to say. If you take, where's my eraser? If you take this out and you just have BH together, it's just showing you that you don't have to have any symbols in here. When you have two letters or a letter and a number beside each other, if you have 2B, that means 2 times B. If you have BH beside each other, it means B times H, or base times height, or whatever they stand for. Now, look at the gray box that has the arrow pointing to it. Be careful to use the correct measurement as the height. For height, we need to use the same height we use for parallelograms. Pardon me. The measurement of a line perpendicular to the base is going to the top of the shape, not the length of the side. Now, it's important to note that it's not necessary to draw a parallelogram around a triangle to find its area. They just did that. It says to just illustrate why it's half times the base times height. You don't, when you have a worksheet that tells you to find the area of a triangle, you don't have to draw that, is what that's saying. You just know that it's half of it. Now look at what's in bold letters there in the middle of the page. All we have to do to find the area of a triangle is multiply half times the base times the height. Example, find the base times the height and then divide that by 2. So here's some examples. So look at A. Alright, so remember it's A equals half times base times height. Two different ways to write it. So for triangle A, the area equals half times the base is 59.5 millimeters times the height, which is 59 millimeters. that equals 1,755.25 square millimeters, or area equals 59.5 millimeters times 59 millimeters divided by 2. Figure it all out. It still equals 1,755.25 squared millimeters. Notice it's squared. The millimeters are squared. Sorry, I got sidetracked. So look at triangle B. Again, half times base times height. You see the numbers that they put in there from the triangle, and did all the calculations. But remember what I was saying earlier is that when you figure area, your answer is always squared. Notice that little tiny 2 up there beside the millimeters. That means that they were finding area, which means they used little tiny squares. Not really, but that's how you find area, is you use little tiny squares inside the area of the shape that you're trying to figure the area of, and that's why it's squared, because you use squares. Okay, and then notice how they did C, same thing. Always remember, you need to always make sure that you write your formula first. If you've got 10 problems, write your formula first. Then the next step is write it again, but plug your numbers in where they go. And then the third step should be finding your answers. Okay? Now, look at the keeping perspective. Even though not too many objects we find in nature look like a triangle, triangles lend themselves well toward helping us explore many aspects of creation. For example, we'll see in the next lesson how they aid in finding the area of various other shapes. All right, so let's look at worksheet 17.1. It's going to have front and back. So you're going to get to use the calculator, it looks like, on every section except 5. You won't need it on 5. All right, so make sure and have your calculator out. I'm going to help you with the first 1 or 2. I need to get my calculator out too, so you can see it. All right, there we go, fancy schmancy. All right, so find the area of these triangles. Now, you'll need to, let me clear my page. You will want to write your formula first. I know you think that might be, oh my gosh, it's just wasting time. It's wasting paper. It is not. It is not. So, on number 1, do this. Area equals half base times height. That's all you have to do on each one of those. Okay, now what we're going to do is we're going to fill in our numbers. So our next step would be this. A, remember A is what we're looking for. That's area. Okay, we've got half times, okay, what's the base on that first one? It's 21. And the height is 10. Okay, so the area equals, now we got to figure out our calculations. Best way to do it is to say 21 times 10 equals to 10, and then divide that by 2. So 105. So your answer then would be 105, but now we have to label it. It is square feet with a little 2 to show that they used square feet in measuring the area of that triangle. All right, let me help you with B. And then I'm going to turn it over to you and let you finish it. All right, first things first, write your formula. And you may not want to write it the way I did. You might want to write it like this. And that's fine. It doesn't matter. All right, so now we wrote our formula, so now let's plug in our numbers. All right, so the base is 16. What's the height? 10. Divide that by 2. Area equals, let's bring our calculator up. So 16 times 10 divided by 2 gives us 80. but we also have to label it. It's square inches. That would be your answer on the second one. All right. All right, so go ahead and finish the rest of the page. It'll be pretty easy as long as you remember this. Plug in your numbers and just think it through. I'm not going to grade this page. I want to see it, and I want to make sure you understand it so that you'll do well on the quiz, okay? That's all for today.